Oops.
Oh, no worries. Hello, everyone. Welcome to another First Flights at Cyphren. So today we're going to be running through a very exciting code base. It's very different from the ones we've seen in the past. So today we have Patrick Collins here to support us as we go through this code base. Should be quite fun. My name is Juliette. For those of you who don't know, I'm leading DevRel here at Cyphren. And we have Patrick Collins, teacher, developer advocate, CEO of Cyphren, security researcher, who will be taking us through some of the deep dives and the cool things of the code base as we go through. So, Patrick, hello.
Hello. Thank you for the intro, Juliette. Let's do it. What's up, gang? We got a special one. So for those of you who checked it out already, you already know we got a special one. We have a lot of Huff. So let me talk about what this code base is, what's going on here, and whatnot. So open up, let's open up the README. Let's talk about this beautiful code base here. Yes. So the logo doesn't look great on my dark screen here. But here is the stats, and here is about the project. Feel free to take some time to read this. But essentially, this is a strategy that we've seen in the past where a protocol will actually write what's called reference contracts in Solidity, and then they will write a gas-optimized version of that code base in either Yule or assembly, etc. So we have a link to Seaport, which is actually kind of the inspiration from here. And this actually could potentially be the future of smart contracts in a world where we see, every single gas being super important to be hyper optimized. Okay. So what a protocol will do is we'll see something similar to what we have set up in our code base here. If we go to our SRC, we see there's actually a couple different files in here. We have horse store.sol, which is kind of this very small minimized code base, right? It's barely 50 lines long, and most of these are comments. You import ERC20, ERC721, got a couple functions in here, and this is the Solidity implementation, and we say, okay, how can we write this even more gas efficient? Let's rewrite it in Huff. Huff is a very low-level language. It's kind of nearly equivalent to like writing your smart contracts in assembly, like in opcodes, like every single opcode, like basically you're going to write. And so this Solidity here is the reference contract for this Huff code, which is a lot more code. Now I should have probably so I did a couple. So in Huff, you can do imports. I imported like hash map and common errors. I probably should have imported the ERC721 implementation of HuffMate as well, but I didn't do that. So in this code base, kind of down nearish towards the bottom, we have this ERC721 methods. Everything below this comment is going to be basically copy pasted from HuffMate. Basically, I guess that's a hint right there. But the rest of this is Huff code. So right, this is hyper gas optimized Huff code, where it's literally low level. And one of the things that I love about Huff is, for those of you who don't understand Huff, it is probably the best language for learning low level EVM, low level opcodes. If you can write Huff, I kid you not, you can go to any contract on the Ethereum ecosystem, read the bytecode, and understand what it's doing. That's like, if you understand Huff, you can do that, which is insane, right? Most people, when they read a smart contract, they're like, if it's not verified, they go, impossible. You can't understand what this is doing, but you can, right? And so there's actually tools called disassemblers, which will try to convert like the bytecode back to Solidity code. If you write your code in Huff, they wouldn't be able to do that, but maybe you have write a disassembler that tries to rewrite it to Huff. Anyways, phenomenal language for learning low-level EVM, which will make you a better auditor, which will make you a better smart contract developer, etc. Now, I will say on most of the code bases that you auditors will be auditing, they won't be written in Huff, and you probably won't even need to be super EVM savant. But there are some code bases where you will, right? So like we at Cyphren, we've done audits before on code bases that use, 100-line Yule functions. And the only way for you to be able to know what those are doing right here is if you understand how these work, how memory works, how it really works at the low level. And Huff is a great way to do that. So this is going to be a little more challenging than what was going to happen in part 2 of the security course. So in part 2 of the security course, we're going to have a minimized version of this horse store. This is the slightly harder one because I wanted to give you plenty of chances to find bugs. But that's kind of the summary of it. So essentially, like I said, we have 2 implementations of this. We have the Solidity rendition, which is the reference contracts, and then we have the Huff edition, which is the actual contracts that this protocol is going to store. I said, for the purpose of the first flight, I said they are equestrian lovers, so I guess I'm pretending to be the protocol. So I'm an equestrian lover, and they just love all things horses. And the purpose of this project is just to be a commemorative to horses in general. I guess I'm like Ryan Gosling from like Barbie, I guess. I don't know. Anyways, so they love horses. They made an NFT about horses, but here's the thing: horses are fast and they don't burn gas. So they wanted to write the contracts in a way that was fast, doesn't burn a lot of gas. Horses burn oats, instead. So there's a horse. Huff is also a horse-themed language. This is a horse-themed project. A lot of horses here. Anyways, there's 3 main functions in this protocol, and you can actually very easily see this in the Solidity. We have mint horse, feed horse, and is happy horse. That's it. These 3 is the main functionality of the protocol. People should be able to mint themselves a horse-themed NFT. They should be able to feed their horse, which doesn't do anything other than just updates this mapping. And then they should be able to check if their horse is happy. And the horse is happy if and only if it has been fed within the last horse happy if fed within seconds, which is set to 1 day. So whatever 1 days in seconds is. That's it. So this Solidity code base tells you the functionality. Well, excuse me, the README tells you all the functionality. And it actually talks a little bit more about these variants. Hey, if it hasn't been fed in the past 24 hours, if it has been fed within the past 24 hours, the horse X must be happy. Horses must be able to be fed at all times. Those are kind of the most important invariants for this protocol. If you find something that breaks one of these, boom, you've found a high, because this is the main intent of the protocol, and that would be considered a severe disruption of the functionality of the protocol. Yes, it's kind of silly. It was meant to be kind of silly. I didn't want to hit you guys with like an AMM written Huff. That would have been awful. So plus I would have had to write an AMM in Huff, and I didn't want to do that. So here's some hints. Obviously, if you don't even know Huff, maybe you can write some tests, right? And this is actually where the power of understanding mature test suites can come into play. Maybe there are some bugs just by them writing better tests, etc. And with the audit criteria here, any of those 3 contracts is in scope. So this is a little bit different, right? If you find an issue where the Solidity code base is not representative of what the protocol is supposed to do, that should be considered a security vulnerability. If you find any issue in the Huff code, obviously, same thing. And then additionally, if you find any issue where the horsestore.huff functionality doesn't match the horsestore.sol functionality, not including gas costs or specific storage slots, that should be considered a vulnerability as well. So for example, if you call mint horse on the Huff contract and you call mint horse on the Solidity contract, and they both end up in different ending states with the same starting state, that's an issue. For example, if you call, if storage slot 0 has a 7 in the Solidity and 7 in the Huff, you call mint horse, and now it has a 12 and a 15 in that storage slot, boom, that doesn't match. That should be reported as an issue. Cool. And in here, we have obviously the getting started, scope details, any of these. We have compatibilities. You can read these as well. And then we have some known issues. The exact 20, don't report any issues where like, oh, like Ethereum has 12-second block time. So it could be 24 hours and 2 seconds. Like ignore that. Anything outside it, if you find a way to disrupt the 24-hour fed horse time frame by more than 2 minutes, report that. But anything within the 2-minute window, please ignore. The chains that this are deployed on are Ethereum and Arbitrum. Theorem has 12-second block time. Arbitrum, I'm sure, is much shorter. So you pretty much should always be within those timeframes. But if you can find a way to make it longer, report that. Any gas inefficiencies or gas efficiency differences should also be ignored. And the exact error opcodes, error names might be different in Huff versus Solidity. Please ignore those as well. And that's pretty much it. So to run this, you need to have a bunch of stuff installed here. Scroll up to the top or scroll down here. You need Git, Foundry, and the Huff compiler as well. So that's going to be probably one of the most challenging parts of this is downloading the Huff compiler. Because in order to run this, you need to be able to obviously compile Huff, right? So when we run this, we're going to run make. I already ran make, so it's already all set up, but I can run like make test. Maybe I didn't run make. What did I mess up? Install. Am I in the wrong folder? All right, so I might have to go back and fix something. I thought I'd fix this. Do this. Sorry about this. I made this last night. Oh, git stash. Oh, I don't want to push.
No worries. I think you may want to just like remove the repository and install and pull it in again.
I'm going to reset to the.
Nice.
Yeah, I guess what I just did was essentially the equivalent of deleting it and restarting. So you run make to install everything, unless I messed up and I have to fix the README. If I have to fix the README, sorry about that. I will. Equius says he fixed it in the repo, so thank you, Equius.
Equius rocks.
Okay, there we go. Cool. So I must have messed something up, but it's good now. Yay. And boom, you run make test and you run all the tests here. Now, what's cool about the test setup, and then I do have to jump off. I'm super late for another meeting. I'll let Jules take it from here, is we have actually kind of a novel test setup. So we have this abstract contract based test. This is actually kind of inspired by the Sabler V2 code base. If you haven't checked out that code base, definitely check that shit out. It's an awesome code base. So, but all the tests are in here, but this code won't actually run. The code will only run in actual contracts, so it won't run in abstract contracts. So when we see, there should be horse store huff test, but whatever. This horse store huff is base test. So it'll run all the tests of the base test, but you don't need to write them in here, which is really nice. And this one is for the Huff contracts. And then obviously we also have one for the Solidity contracts where this is completely blank. And the reason it's completely blank is because in the base test, we set up the Solidity contracts. So it's a bit of a novel approach here. And the idea behind this is that every single test in here is going to, the exact same test is going to run on the Huff code and the Solidity code. And this is to ensure your test suite always runs on both code bases. And like I said, even if you don't know Huff, if you understand good testing methodology, maybe that's all you'll need for this audit. So with that, I got to jump. I will let Jules take it from here. Thank you all so much. Hope you have fun with this one. This is definitely a great one to learn Huff if you do not already know Huff. I will tell you right now, for those who are on this call, there is at least one bug in the Solidity reference. So even if you don't know any Huff, you can find at least one bug. And I will also tell you there is at least one bug in the Huff as well. So good luck, have fun, and I'll see you next time.
Amazing. Thank you so much, Patrick, for that rundown. Bye, guys. Right. So that was very cool. I'm personally very excited to dive deeper into Huff Certainly, I think if there's no other reason than just to dive deeper into upcodes and compiler methods, then that's good enough to start diving into Huff and seeing what that can provide for this code base. And I think also just that exciting part of testing whether the bugs are in Solidity and Huff, the output of those, if those are different, that's certainly a space to look. I'll offer some additional tips that I'm always keeping in mind as we're going through these. So always check out the code base context, read the documentation, just like Patrick just did, the invariants, what is it supposed to do? And at any times that the code base doesn't do exactly what the documentation says, then that's certainly a space for an exploit and a high. Running through all the README methods, kind of like what we just did, making sure all the tests are running, having your repository locally, that should be super helpful. Also digesting the code base in chunks. So trying to first get maybe like a high level diagram of how the repository is putting together, then maybe diving deeper into some nitty gritty of what the function does. Having that mental model should be super helpful as we're diving in through these. Also the versions. So what's the version of the compiler for Solidity? What's the version of the compiler for Huff? Are there any known bugs in each of these versions? Looking at Solidit there should be incredibly helpful, as well as additional Solidit findings that may be similar to doing similar things to what our current code base is doing. That's certainly a good place to look. And then just getting yourself familiar with like roles, access controls, parameters, entry points within the protocol. That should be incredibly helpful. And running, of course, any static analyzer like Slither, like Adderin, which may give you a better overview of where some of the weaker points are within this code base. So thank you so much, guys, for your time. If you have any questions, happy to go through them. I see some here. When Cypher and Huff course, it's not in the works, I'll admit. But if we get some demand, then certainly might be worth pushing through that. Thank you for the push. You can. Then we have another question here. What do you mean by between two findings in second known issue? Maybe if you could elaborate a bit more on that question. I'm not sure I know what you're referring to. But I think what Patrick was meant to be saying there is that we have two contracts. One of it is in Solidity, another one is in Huff. And so the idea is that you want to get the exact same output on both. And if there's a change there, if you're able to do something in Solidity that you're not able to do in Huff or vice versa, then that's certainly a bug. So make sure to look out for those and use the Solidity one as a reference, essentially, of what the code base is meant to be doing. All right. Well, good luck, guys. And hit us up if you have any questions. We're on the Discord. We're there to support you and get all these exploits out. So more than happy to go through those or dive in more depth into any of the concepts within the Discord asynchronously. Have a good day, guys.